In this video we're going to be looking at chemical formulae and relative mass. Now the basis of this entire topic, topic 3, quantitative chemistry, is the ability to construct balanced simple equations. And that is simply not possible if you are not first able to identify the correct formulae of different chemical substances, different chemical compounds and molecules. Now there are a number of them that you need to just know and have that by memory, and there are others that you need to be able to work out. Okay, so starting off, we've got some covalent compounds, some covalent molecules that you need to know the formulas of. So we'll start off with the diatomic elements. Okay, iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, fluorine. These are the only 7 diatomic elements that you need to know of. And by diatomic, which simply means they form simple molecules containing 2 of the same atom. Now, there is a mnemonic that you can use to remember the 7 diatomic elements, and that is I have no bright or clever friends. Okay, I for iodine, H for hydrogen, N for nitrogen, Br for bromine, O for oxygen, Cl for chlorine, and F for fluorine. So that mnemonic will help you remember the 7 diatomic elements. Obviously we have water, H2O, carbon dioxide, CO2. Now by now we've been using these all the way back since year 7, and they should already be committed to memory. When we did topic 4, chemical changes, we covered acids and bases, and there were 3 acids that you needed to know their name and their formula. So we've got hydrochloric acid, HCl, nitric acid, HNO3, and sulfuric acid, H2SO4. You need to memorize these formulas. And then we've also got some of the organic molecules from topic 7, organic chemistry. Now, you don't necessarily have to memorize these, but you do need to know from their name whether they are an alkane or an alkene. So if it ends in ane, it is an alkane, and if it ends in ene, it is an alkene. And we should know that the general formula for alkanes is CnH2n plus 2. And the general formula for alkenes is just CnH2n. So you can identify whether it's an alkane, whether it's this formula, by the name. Ethane ends in ane, so it's an alkane, so it must have this formula. Ethene ends in ene, is an alkene, therefore it has this formula. And in terms of filling in the numbers, well, N represents the number of carbon atoms. So if I had 1 carbon atom, I would need twice as many hydrogen atoms plus 2, which is actually methane. That's why you get CH4, because if C is 1, then 2 times 1 is 2, plus 2 is 4, giving us CH4. Now, to identify how many carbons are in that molecule, we look at the beginning of the name. If it begins with meth, then it has 1 carbon. If it begins with eth, then it has 2 carbons. If it begins with prop, it has 3 carbons, and if it begins with bute, it has 4 carbons. So as long as you know that if it begins with meth, it's 1 carbon, eth, 2 carbons, prop, 3 carbons, bute, 4 carbons, and from the second half of the name, ane or ene, tells you which one of these formulas to use, then you can create all of these chemical formulae. Now, with ionic, you are less required to remember any of them, but be able to work them out. So I'm going to start off with ionic compounds that only contain 2 elements. So we'll start with aluminium oxide. Now, the first step is to write out the formula of both ions in the compound, including their charge. So in aluminium oxide, we have aluminium and oxygen. And we can identify their charge by finding them on the periodic table. So aluminium is here. It is a metal, so it's going to be positive, and it's in group 3. So it's going to be plus 3. Remember, metals lose all of their outer shell electrons when they form ions. So aluminium we can identify as being a metal because it's on the left of the staircase. Now the staircase, if you just draw a line between boron and aluminium and then just go down in steps from there. Everything to the left of that, with the exception of hydrogen, everything to the left is a metal. So these are all metals. So they are all going to lose their outer shell electrons to become positive ions, and these are all non-metals, and they're going to gain electrons to become negative ions. So aluminium's in group 3, which says it has 3 electrons in its outer shell, and it's a metal, so it's going to lose all 3 of those to become 3+. Oxygen is in group 6, and it's a non-metal. And non-metals gain electrons in order to get a full outer shell. It already has 6, a full outer shell would be 8, so it needs to gain 2 electrons, which is why the oxide ion is 2-. So step 1 is identifying the charge of the ions, aluminium 3+, oxide 2-. The second thing you do is you look at the numbers of those charges. Whether they're positive or negative is not important, just look at the numbers. So Al3+, oxide 2-, and you just move those numbers diagonally. So you move the 3 from your aluminium to your oxygen, and the 2 from your oxygen to in front of your aluminium, and rewrite it. So aluminium 2, oxide 3. And that is now the correct formula for aluminium oxide. The last thing to do is double check that the overall charge of the compound is 0. So the aluminium was 3+, and I've got 2 of them here. So I've got 2 times plus 3, which is equal to plus 6. I've got 3 lots of oxide, and the oxides were all 2-, so I've got 3 lots of -2, which equals to -6. Plus 6 minus 6 overall is 0. In this second example, I've got what we call a polyatomic ion. Now that is an ion that contains more than one element. Okay, it's got sulfur and oxygen in it, and that means you cannot work out its charge from the periodic table. There are some polyatomic ions that you just need to know the charge of. Once you know it, so if you know sodium sulfate and you know that sulfate is SO4 2-, you can still construct the formula using the exact same method. So sodium is in group 1, and it is a metal, so it's going to lose that 1 electron and be +1. The sulfate you can't work out from the periodic table, you just need to have committed that to memory, that sulfate is SO4 2-. And when we're dealing with polyatomic ions, we always draw them in brackets and we keep them in brackets. And we're going to do the exact same thing. We're going to look at the number of the charges. It doesn't matter if they're positive or negative, we're going to ignore that. We're just looking at the numbers, and we're going to move that diagonally, and we're going to move it. When we've got a polyatomic ion with brackets, we're going to move that number to the other side of the brackets. And we're going to move that to the same way we did before. What that leaves us with is Na2 SO4 1, which we can include it if we need to, but it doesn't make any difference. And then to check if we're right, we need the overall charge to add up to 0. So we'll look at the sodium. We've got 2 lots of +1, which equals +2. The sulfate, we've got 1 lot of -2, which is equal to -2 plus 2 minus 2 equals 0. So here we have the polyatomic ions that you need to know, and these are going to be things you have to commit to memory. So we have hydroxide, OH 1-, nitrate, NO3 1-, sulfate, SO4 2-, and carbonate, CO3 2-. Now, whenever we write polyatomic ions, they won't always necessarily in the exam question be put in brackets, but it's a good habit to get into, because then you're less likely to get confused about how many of each atom you have in your compound. So we've got some examples here of different ionic compounds where you need to write the ionic formulae. So I'm going to do a few examples, and you should be able to apply the method from the previous page in order to fill in the rest. So we'll start simple. We'll look at sodium chloride. So in sodium chloride we have sodium ion and a chloride ion. Now the fact that it ends in "ide" tells us that it's chlorine on its own. Notice how when we're talking about our polyatomic ions, it's not nitride, it's nitrate, which tells you it's got oxygen. It's not sulfide, it's sulfate, which tells you it's got oxygen. It's not carbonide or carbide, it's carbonate, tells you it's got oxygen. So the fact that it's chloride tells you it's chlorine on its own. So to identify the charge, we should straight away be able to say sodium is a metal and chlorine is a non-metal. So we should be able to identify that the metal is going to be positive and the non-metal is going to be negative. You're not expected to memorize all of the metals, all of the non-metals. So if you're unsure, grab your periodic table, find sodium, it's to the left of the staircase, so it's a metal. Chlorine is to the right of the staircase, so it's a non-metal. Everything on the left is a metal and will form positive ions. Everything on the right is a non-metal and will form negative ions. So how positive and how negative? So sodium is in group 1. Metals lose all of their outer shell electrons. And if it's in group 1, it's only got 1, so it's going to be +1. Chlorine is in group 7, which means it has 7 in its outer shell. It wants a full outer shell, which is 8, so it needs to gain 1 more, making it -1. And then using our method from before, you can move the numbers diagonally. Now, if the numbers are just the plus and minus of each other, so +1, -1, straight away you know that balances. +1 -1 equals 0. So we can move straight to our answer. It must be a 1-to-1 ratio, NaCl. So let's look at another one, calcium oxide. So it's got calcium, and because it ends in "ide", you know it's oxygen on its own. So calcium is a metal, because it's over here on the left of the staircase, and it's in group 2. So it's going to be +2. Oxygen is a non-metal, and it's in group 6, so it needs 2 more to get to 8. So it's going to be -2. Now again, we can see that these two numbers are the same. +2 -2 is going to equal 0. So our formula is going to be CaO. Let's look at beryllium phosphide. Again, ends in "ide", so that's going to contain beryllium and phosphorus only. So beryllium is in group 2. It's a metal and it's in group 2, so it's going to be +2. And the phosphorus is a non-metal because it's to the right of the staircase, and it's in group 5. So it needs 3 more electrons to get to 8. So it's going to be -3. In this case, these numbers do not cancel each other out. So we're going to have to use our diagonal method. Move those numbers. So we're only moving the 2 and the 3. We're not moving the plus and the minus. And by moving that, we end up with Be3P2. And again, we can double check that that's going to balance to 0. Well, if I've got 3 lots of +2, that's +6. And if I've got 2 lots of -3, that's -6. +6 - 6 equals 0. Okay, the next one I'm going to look at is magnesium hydroxide. Now, this one, hydroxide, that's one of our polyatomic ions. It's OH1-. So we're going to write that, Mg, and we're going to keep it in brackets, OH1-. You can't look this up on the periodic table. You have to just know it. The magnesium, however, we can look up. It is in group 2. It's a metal, so it's going to be +2. So if I'm looking at these 2 and 1, they're not going to cancel directly. So I'm going to use my diagonal method to move those numbers across. And remember, you move it to the outside of the bracket. So in this case, I'm going to have Mg1. You can put the 1 there if you want, but it's not necessary. Brackets OH2. And again, check it adds up. The magnesium is +2. I've got 2 lots of -1, so that's -2. +2 - 2 equals 0. The next one we'll look at is calcium nitrate. Again, nitrate is one of those polyatomic ions, NO3 1-. So calcium nitrate, NO3, 1 -. We can't look this up in the periodic table, we just need to know it, but the calcium we can look up. It is a metal and it is in group 2, so it's going to be +2. And again, we're looking at these two numbers, they're not going to cancel each other out, so we need to move them diagonally, which is going to give us calcium 1, which we can include if we wanted to, but don't need to, brackets NO3, 2. Okay, so that 2 there is telling us that we have 2 lots of nitrate ions. So again, we can double check that this all cancels out. The calcium is +2, and we've got 2 lots of the 1- nitrate ion, which will be -2, +2 -2 equals 0. If we have a look at magnesium sulfate, again, polyatomic ion. We've got magnesium, and we've got sulfate, which is SO4, 2-. Again, you have to know that, you can't look up on the periodic table. The magnesium is in group 2, it's a metal, so it's going to be +2. And here we can say that +2 -2 is going to equal 0, so all you have to do is write it as MgSO4. +2 -2 equals 0. So if these two numbers are the same value, the same integer, +2 and -2, or +1 and -1, or +3 and -3, then it's just a 1-to-1 ratio. It's only when the numbers are different that you have to do the crossover method to get the ratio. And the last one we're going to look at is sodium carbonate. So sodium and then carbonate, again, one of the polyatomic ions that you need to know because you can't look it up. CO3, 2-. Sodium is in group 1 of the periodic table, so it's going to be +1. +1 -2 doesn't equal 0. So again, we're going to take those numbers, we're going to move them diagonally to the outside of the bracket, giving us Na2, CO3, 1. You can add the 1 if you want to, but you don't need to. And again, double check that that adds up. Well, 2 lots of +1 is +2, -2 equals 0. So if you just apply those methods, if you want to refresh your memory, then just go back to the worked example on the previous page, and you should be able to work out the chemical formula of all of these ionic compounds, which is a skill that you're going to be required to do in order to complete an equation before you could then go on to balance it. Now, relative formula mass is simply the sum of all of the atomic masses of all the different elements in a compound or a molecule. So we can use this formula to explain it. So the relative formula mass is the sum, so this is the symbol for sum, just means the total of the atomic mass of all atoms in a compound or molecule. So this relies on your ability to be able to read chemical formulae to identify which elements are present and how many there are. So we use 2 things to in order to work this out. Number 1, we have chemical symbols. Every element has a unique chemical symbol shown in the periodic table. Every element begins with a capital letter. So you can work out very quickly how many different elements you have by counting the capital letters. So here in aluminium oxide, we've got a capital A and a capital O. So we've only got 2 elements. So we've got Al and O. Al is aluminium and O is oxygen. If we look at this example down here, we have 3 capital letters. We have a capital G, capital S, capital O. So we have Ga, gallium, S, sulfur, O, oxygen. So by looking for capital letters, you can identify how many different elements you have each time. Once you've identified which elements you have, you need to identify how many you have. And that is indicated by these small subscript numbers. If you are looking at a chemical formula and it has large numbers in front of it, that does not tell you how many atoms are in a compound. That just tells you how many of that compound or that molecule you have. So for example, if it said 2H2O, that's telling you you've got 2 molecules of H2O. Each one of those still only contains 2 hydrogens and an oxygen. So we're only interested in these small numbers. When we're looking at relative formula mass, we're only interested in these small numbers. So the first thing to do is identify the atoms present. Well, here I've got aluminium and I've got oxygen. And using the little numbers, we can see that I've got 2 aluminiums and I've got 3 oxygens. The second thing we want to do is find their atomic mass values from the periodic table. Now, on the periodic table, you are given 2 bits of information for each element. You are told its atomic number and its mass number. But its mass number is the same as its relative atomic mass. So if I took carbon, for example, it's got an atomic number of 6, which means it's got 6 protons, and it has a mass number of 12, which means it has a total, if you added the protons and neutrons together, it would add up to 12. But it also means it has a relative atomic mass of 12. So we find their atomic mass values from the periodic table. So we're looking for their mass numbers, the large number. So aluminium is 27. And oxygen is 16. Now sometimes these values will be given to you in the question, but if they're not, you've simply just got to look at the periodic table. So multiply the atomic mass of each element by the number of atoms present. So for aluminium I've got 2, so it's going to be 2 lots of 27, which is 54. And for oxygen I've got 3 lots of 16, which is 48. And then finally, add it all up. Add up the total mass of all the individual elements. So 54 plus 48, giving us 102. And that is the relative formula mass of aluminium oxide. The next example then, gallium sulfate. Now this one contains a polyatomic ion, the sulfate, SO4. And it does get slightly more complicated because in the bracket, that is the sulfate ion, SO4. But you'll notice outside the bracket we have a 3, which means we have 3 lots of everything in the bracket. So in the bracket I've got 1 sulfur. So I need to multiply that by 3. So I'm going to have 3 in total. In the bracket I've got 4 oxygens, but I've got 3 lots of the bracket. So 3 lots of 4, giving us 12 oxygens in total. So remember, when you have a bracket, the little number, the subscript number outside the bracket, multiplies everything in the bracket. And these subscript numbers only apply to the element or the bracket they're directly next to. So this SO4, that 4 only applies to the oxygen, not to the sulfur. So identify the atoms present. So looking at, for capital letters, we can identify different elements. So we've got capital G, lowercase a, so that is gallium. We've got capital S for sulfur, and we've got capital O for oxygen. How many of each one of these do we have? For the gallium, we have 2. The sulfur, we have 1 in the bracket, but we've got 3 lots of the bracket, so we're going to have 3 lots of sulfur. And the oxygen, we've got 4 in the bracket, but we've got 3 lots of the bracket, so that's going to be 12 in total. So we've got 2 galliums, 3 sulfurs, 12 oxygens. Find their atomic mass values from the periodic table. So gallium is down here, and we're looking for the large number, the mass number. So gallium is 70. Sulfur, again, use the periodic table. The large number, 32. And oxygen, same as it was before, but if we just double check, 16. Multiply the atomic mass of each element by the number of atoms present. So we've got 2 galliums, so that's going to be 2 times 70, so 140. We had 3 sulfurs, so that's going to be 3 lots of 32, which is 96. And oxygen, we've got 12 lots, so that's 12 times 16. It's 192. And then add up the total. So 140 plus 96 plus 192 equals 428. And there is our relative formula mass of gallium sulfate. Finally, what you're going to be able to do is to complete this table where you are only filling in the white squares. Ignore the ones that are greyed out. So you've been given some information. You've either been given the name of the compound or the formula. So if you're given the name, you need to work out the formula. And if you're given the formula, you need to work out the name. And for every single one of these, you need to calculate the relative formula mass, which of course you're going to need your periodic table to do. So let's have a look at the first example. So we've got sodium chloride. So how would you work out the formula of sodium chloride? Well, I would write out the ions first. We've got sodium and chlorine. Because it ends in "ide", we know it's just chlorine on its own. Sodium is in group 1, so it's +1. Chlorine is in group 7, so it needs one more to get a full outer shell, so it's going to be -1. And then straight away, +1 - 1 does equal 0, which is where we get our NaCl from. And then we just got to look at the relative masses of these elements. Well, sodium is 23. Chlorine is 35.5. We've got one of each, so we don't need to multiply them by anything. So 23 plus 35.5 is equal to 58.5. Right, let's have a look at the second example. So magnesium iodide. So we have magnesium and iodine, and it ends in "ide", so it's iodine on its own. Magnesium is a metal in group 2, so it's going to be +2, and the iodine is a non-metal in group 7, so it needs one more to get a full outer shell. It's going to be -1. These do not cancel each other out, so we're going to have to use the diagonal method, giving us Mg1I2, which makes sense. If the magnesium's +2 and the two iodines together are -2, that equals 0. To get the relative formula mass, we need the mass of the magnesium, which is 24, the mass of the iodine, which is 127, and remember, before we add it up, we have two iodines, so our relative formula mass is going to be 24 plus 2 times 127 equals 278. So if I just put the times 2 there. And the last example I'm going to do is this third one here. So we've got two capital letters. We've got Al, which is aluminium. And we've got a phosphorus on its own. And if it's on its own, it ends in "ide". So this is going to be aluminium phosphide. We don't need to worry about the ions because we've already got the formula. So we just want to know the relative formula mass. Well, the aluminium has a relative mass of 27. And there's two of them. And the phosphorus has a relative mass of 31. And there's 3 of those. So in order to get our relative formula mass, 2 times 27 plus 3 times 31, giving us a relative formula mass of 147. So using everything that we've covered on the previous pages, you should be able to go through this worksheet and identify the ions and the names, the formulas and the names of these ionic compounds, and that once you've got all the formulas, you can work out the relative formula mass of all of these different compounds.